students, how are you? Today we discuss about the application of derivatives part 1, and in this part 1 we studied about the rate of change of quantity. The rate of change of quantity means we have to actually compare with the x and y two variables, and therefore this x and y two variables, it is represented as y is equal to fx. Then x and y corresponding to increment of delta x and delta y, a small change, and respectively the rate of change of y with respect to x is limit delta x tends to 0, delta y upon delta x is equal to dy upon dx. That's we already discussed in limits and in other continuity and differentiability topics. Now here, if x and y are two functions and the third variable is t, then dy by dt is equal to dy by dx into dx by dt. So this dy by dx is written as f dash x as dx by dt. So rate of change of y with respect to x is that the rate of change of y with respect to t, and rate of change of x with respect to t. In example 1, the side of a square metal sheet is increasing at the rate of 3 cm per minute. And what rate is its area increasing when the side is 10 cm long? Here, the side of the square means, what is square? Square means all the sides are equal. And when all sides are equal, then the area of square is x square. And here it is given that the rate of this area is dA upon dt is equal to 3 cm per minute. So given that dA upon dt is equal to 3 cm per minute, and suppose side of square is x centimeter, then area of square is all the square of the sides, and that is equal to x square. So this is dA upon dx is equal to d upon dx into x square is equal to x. I apply the relation that d by dx, x to the power n, is equal to nx to the power n minus 1. But it is given that the dA upon dx, the area is increasing when the side is 10 cm long, and therefore I will write here that dA by dx when x is equal to 10 cm, centimeter square. Now after that, I want to prove that the rate is area increasing when its area, so we have to find out where dA by dt. So dA by dt is equal to dA upon dx and dx upon dt. Here, this dA upon dx is equal to, of course, I find out that x is equal to 10, and this dx upon dt is given that is equal to 3 cm per minute. So dA upon dt is equal to dA upon dx into dx by dt. So dA upon dx, then x is equal to 10. We already calculate that is equal to 20 into 3 is equal to 60 centimeter per square centimeter per second. In the example 2, the total revenue in rupees received from the sale of x units of a product is given by Rx is equal to 3x square plus 36x plus 5 in rupees. find the marginal revenue when x is equal to 5, where the marginal by marginal revenue MR, we means the rate of change the total revenue with respect to the number of items sold at an instant. Here we have to find out that given that Rx is equal to this 3x square plus 36x plus 5, when we differentiate, so this is equal to 3x square plus 36x plus 5. 3 d by dx into x square. This 36d by x plus d upon dx is equal to 5, and therefore this is equal to 3 into 2x. This dx and this dx will be cancelled and remains 36. So this is dr by dx is dx. But what is actually? It's given one more point, that when revenue is x is equal to 5, so dr x upon dx, and this thing is equal to x is equal to 5, so this is 6x plus 36. So 6 into 5 plus 36 is equal to 30 plus 36 is equal to 66. So this is our 66 rupees is your marginal revenue at x is equal to 5. In example 3, find a point on the curve y square is equal to 8x, for which the abscissa and ordinate change at the same rate. What is given? That given is curve is equal to y square is equal to 8x, and dy by dt is equal to dx upon dt. So I just differentiate y square is equal to 8x curve in with respect to t. d by dt y square is equal to into 8x. This is written as d upon dy y square into dy by dt is equal to this dx upon dx into dx by dt. 2y dy by dt is equal to 8 dx by dt, because this dx and this dx is cancelled, so it remains only 8 dx, but dy by dt is equal to dx by dt, and therefore we will write 8y is equal to 8, so y is equal to 4. Substituting the value of y in this y square is equal to 8x. Substituting value of y in y square is equal to 8x. So this 4 square is equal to 8x. So 16 is equal to 8x, or x is equal to So therefore, what we can say that find the point of curve. The point of curve is